Video, we are going to look at molarity, the units of a solution, of concentration. Molarity can be the number of moles of solute in 1,000 cubic centimeters of solution, or in 1 liter. The units are moles per liter or moles per decimeter cubed. You'll find mostly being symbolized with the capital M. Be very careful not to confuse moles and molarity. If somebody says 0.2 m sodium hydroxide, that means 0.2 moles of solute in 1 liter of solution. Example, we have 6.75 grams of sodium chloride in 455 milliliters of water or solution. What will be the molarity? To get this, remember, you can say that now we have molarity is equal to moles divided by the liter. So which means you have 6.75 grams of sodium chloride divided by 452 milliliters. Now, remember, we know the molar mass of sodium chloride is 23 plus 35.4, which is 58.4 grams. That's the molar mass of sodium chloride. So we can say there are 6.75 grams sodium chloride divided by 452 milliliters times 1 out of 58.4 grams sodium chloride, or times 1,000 milliliters over a liter. So that conversion will give us the molarity, which is going to be 0.256 moles per liter. Why do we do all this? We are trying to convert so that we have this 452 milliliters converted into the liters. Because when you divide to get it in liters, it's going to be 0.452. So in other words, you can use this computation and it gives you the same answer. And also converting 6.75 grams in moles, you also get that value. Another example, how many grams of potassium hydroxide are required to make 250 milliliters of a 6.0 molar solution of potassium hydroxide? So remember, we have said that you can now convert the 6.0 mole is the same as 6.0 moles per liter. So now we want our volume in liters. So the 250 milliliters, we can convert it. If divided by 1,000, it can be 0.25 liters. So that means 6.0 if you divide with this, because you know the M will equal to N over V, where M, the molarity, is equal to number of moles divided by the volume. So if you do this, you have 125 milliliters. If you convert this, you have now the 6 divided by 0.25. Or you can just do the same computation like the one we did, and you can get the answer simplified. And you get your answer as... so we are just using the same computation, but it gives you that same value, like what we are saying, that you're saying M equal to N over V, and you can get that value as... Okay, if we try another question here, we are having 125 milliliters of 0.05 moles of HCl or hydrochloric acid. We are identifying what is needed. They want the molarity. But remember, we are having the volume and the number of moles. We said molarity is equal to the number of moles divided by the volume. So which means you can still have your 0.050 moles divided by 125 milliliters. But remember, you have to change this 125 milliliters to liters. Do the same thing, divide 125 milliliters to liters. When you get 0.125 liters. So which means you say 0.05 divided by the 0.125, and that gives you 0.40 moles per liter. So that's how you can do the computation by using our simple formula. Just always look for what is required, and then it becomes very easy to get your molarity. We can try another question and see how we can come up, assuming this time you're given how many moles of sodium hydroxide are in 38 milliliters of 0.5 moles per liter of sodium hydroxide. Remember, they're asking for moles, so N is not now known, but you're having the volume and you're also having the molarity. So if you have M equal to N over V, we are going to change this formula and make N the subject, which means N is going to be equal to M times V. If you try to manipulate the formula or make N the subject. So which means you have N equal to 0.50 times 0.038 to get, because now we are converting the 38 milliliters to liters, so we shall get 0.038. So when you multiply 0.5 times 0.038, you get 0.019 moles. And that is how we can compute that. Another question here says, how much 2.5 moles per liter of sulfuric acid should you use if you need 0.12 moles of sulfuric acid? So we can still manipulate our formula. We have M equal to N over V, or now we are looking for V. So which means if you change this formula, it will be V will equal to N over M, because that's how you can make V the subject. So to do this, it means you'll have the V equal to 0.12 divided by the 25. And you can get your answer as 0.048 milliliters if you try to do this. 0.12 divided by 2.5, and you get 0.048. That's how you can deal with this. Let us try another question. Now those ones are liters, which means if you want, you can convert to milliliters. It becomes 48 milliliters if you want it like that. So that's how you can deal with such a question. We try another question. If they ask us, how would you make 100 milliliters of a 0.40 molar solution of copper 2 sulfate? If you look at this question, you see you have the molarity as 0.40 molar or moles per liter, and then you are having the volume as 100 milliliters. So which means you can have this one as the same as 0.1 liters. So to do this, if you try to look at our formula, where we said that N is equal to M times V, we can substitute in and have 0.4 times 0.1, which gives you the answer as 0.04 moles. So at 0.04 moles, we can try to see how we can convert this into grams by getting the formula mass of the hydrated copper 2 sulfate, which means it is copper sulfate 5 water, because remember when it's hydrated, it's having water with it. So which means we are going to get the formula mass. Remember, copper in your periodic table, copper is going to be 64, or you can say 60.5. You have sulfur is 32, oxygen is 16, and hydrogen is 1. So we can compute this, and we get a formula mass as 64 plus 32 plus 64 plus 90, which gives us 2249.7. if you try to use the actual values. Because now the actual values, you have copper 63.55, sulfur 32.07, then you have, if you multiply this, if you try to get the formula mass, you're getting 249.7. So this, you have now, remember, number of moles will equal to mass